Hello, welcome to section P.2, and we're going to be on day 1, where we're going to find the slope of a line passing through 2 points and writing the equations of the line given the point and the slope. Up here, definition of a slope. Slope of a non-vertical line passing through 2 points, x1, y1, and the other point, x2, y2, can be shown to be the calculation y2 minus y1 over x2 minus x1, which sometimes we refer to it as the difference of the y's over the difference of the x's. And in class somebody said it's the rise over the run. And then they asked me why I spelt rise wrong. And I did that intentionally because then I can think of rise, the y's are on top, and run then we'll leave the x's for the bottom. Looking at a negative slope, I just want you to sketch in a picture of a negative slope. It is falling, isn't it, to the right? Because then we have, moving down and to the right. Down would be a negative movement, right would be a positive movement, and negative for the y's divided by positive for the x's would give me an overall negative slope. Zero slope, nice horizontal line. That means that I have zero change in the vertical direction between those 2 points there, and then I could have some value of a change going on between the 2 points in the x direction, and 0 divided by any number turns out to be 0. Positive slope rises to the right, and we can check that out. If I have a point here, I can go up, which is a positive movement in the y direction, and right, which is a positive movement in the x direction. So positive divided by positive, of course, yields positive. Maybe you said, well, I'm going to start here, then I'm going down, which is negative, and left, which is negative in the x direction, and negative divided by negative equals positive. So no matter which way you count, you can get a positive slope there. And finally, an undefined or no slope vertical line. If I have 2 points here, I have a vertical change in the y direction, don't I? I've got a change in y. So I have some number for a y direction. But horizontally, I have zero change in the x direction. This division by 0 will produce an undefined slope for us. All right. Next question, what types of lines cause the steepest slopes? Well, the type where we get a large number over a small number, where I have a very large positive value. That would generate a very steep slope, wouldn't it? Slopes can be thought of in 2 different ways. Let me get this screen to shift on us. There we go. Slopes can be thought of in 2 different ways. If the x and y axes have the same unit of measure, the slope has no units and is considered to be a ratio. The ratio of 2 numbers. Like I could have a change vertically of so many feet over a change horizontally measured in feet, and I'd have feet over feet, which, have the same units on top and bottom. You could almost consider that those units cancel each other out, and I'm left with a ratio. Pitch of a roof, the pitch of a roof on a house. So many feet up, traveling horizontally, so many feet, we could consider it a ratio. If the x and y axes have different units of measure, the slope is considered a rate of change. I can travel so many miles over a change of so many hours, and there we get a rate of change, miles per hour. Let's summarize the equations for linear functions or lines. General form, ax plus by equals some value c. And we have some restrictions here where a, b, and c are integer values, meaning they cannot be fractions. This also is sometimes referred to as the standard form, isn't it? You may have seen that in other classes. Point slope form. Y minus y1 is equal to m times x minus x sub 1. Information needed. Well, we need a y1, whoops, let's start with x. We need a point, whoops, not sure what's going on there, guys. We need a point such as x1 comma y1. The other thing we need to know is our slope. So if we have those two things, we can write point slope form. Slope intercept form will be y equals mx plus b, where m is our slope, and then b is the y-intercept point, or intercept value, I should say, which really is the point 0 comma b. Horizontal lines have zero slope, so you could almost see this where the 0 would be there, 0 times x plus b, but 0 times x would create 0, and we get y equals just some number. Could be b, but it could just be any number. Y equals a number, and vertical lines are x equal some number. Example, sketch a line through the point and then write these lines with these 4 different slopes shown there. So let's go plot this point negative 4, 1. There's my point. First one, let's make a slope of 3. Well, that's like 3 over 1, isn't it? Rise over run. So let's go up, change of y of 3. 1, 2, 3, and then to the right by 1. Here's the point then. And I just need to put a line to connect those. There is equation B. A slope of negative 3, well, then I'm going to count down 1, 2, 3, and then to the right by 1. That should generate a negative slope for me. There's my equation B. Next one is 1/3. Up 1 over 1, 2, 3, and here is my 1/3 slope. That would be C. Finally, having a slope of 0. 0 is a horizontal line passing through our original point. There is my D. Number 14 would like us to calculate the slope, and we're given, a 0.1 and a 0.2. So y2 minus y1 over x2 minus x1, our slope will be, I'm going to take my y2, this negative 1/4, subtract the other y value of 3/4, divide by x value of 5/4, that would be my x sub 2, minus my x sub 1 of 7/8. The top is not hard to do. I can put fourths together. This would give me negative 4/4. But the other one is not quite as clean, is it? I need like denominators, so let's just quickly multiply by the fraction 2 over 2 so that we get this into eighths. So this is 5/4 is the same thing as 10/8. And now I can take 10/8 minus 7/8 gives me 3/8. Dividing by a fraction divided by a fraction, is like multiplying by its reciprocal. And I switch this down to 1. Negative 4/4 is the same thing as 1. So I get negative 1 times 8/3 gives me negative 8/3 as my slope. Find the slope in the y-intercept, if possible, of the line x plus 5y equals 20. Well, this is in a standard form, and I think I'm going to shift it into slope-intercept form. How about that? Slope-intercept form, and if you recall, what does that look like? Well, that's our famous y equals mx plus b. because then I'm going to be able to get my slope as well as my intercept once I adjust this equation. So take my equation. I want to solve for y. And that's going to look like 5y equals negative x plus 20. I subtracted x from both sides. Divide by 5. I'm going to have negative 1/5 x plus 4. And now I found the slope. Slope was equal to negative 1/5. And my y-intercept value is 4. Next question asks us to find an equation of the line that passes through the points and then sketch the line. Well, if you just look at this, we did this in number 14, or the one above 23, which I think was 14. We've already calculated out that slope, and it was negative 8/3. So I'm going to steal that, so I don't have to redo that. And it passes through the points. So I actually have 2 points, don't I? I've got point 1 and I've got a point 2. I'm going to go into that point slope form of the equation of a linear function, and that's going to look like y minus y1 equals the slope x minus x sub 1. Take your pick. Which would you rather use, point number 1 or point number 2? Personally, I'm going to use this one because it had nice positive values, and then I've got this slope of 8/3. So y minus my y value of 3/4 is equal to negative 8/3 x minus my x value of 7/8 tied together there. There we go. You really would not need to clean this up. This is a perfectly acceptable form of the equation. You could leave it like that. If you wanted to, I guess you could bring the 3/4 over by addition. So I could write it out that way, y equals. That'd be fine too. And if I really wanted to get fancy, I guess I could distribute and then put like stuff together. All right, to sketch the line, I think what I'm going to do is make a scale of 4 units. 1, 2, 3, 4 on this. And 1, 2, 3, 4, negative 1, 1, 2, 3, 4, negative 2. And let's plot out one of these points. 7/8 and 3/4. 7/8 would be midway of that last square up to 3/4. There's my first point. Now I can move either by the slope, or I'm going to just go plot my other point of 5/4, negative 1/4. And that'll be there, and then put a line on it. That should do it. I have homework set up for you. There is day 1 from section P2. So good luck.